The decimal number system, we have 0 to 9. Any doubts in this? The set has 0 to 9. So after 9, we have to write 1 0, no? Yes or no? What is next to 9? 10.
10.
But actually, in the 2 digit, what is the first number? Is it 10 or 00? In 2 digit, what is the first number? Is it 00 or 10? For example, I started with one digit decimal 0. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Now the one digit set is over. Then I should go to two digit set. No, what is the beginning in the two digit set?
10. 1 0.
10 or 00?
10.
1 0.
How? It should be 00, no?
Sir,
0 0. Then we have to write 0 1. Then 02, then 03, then 04. So it goes on like this. Then 09 and 10 should come, no? Am I correct? Yes or no? But why do we take 10? How many of you understood this? How many of you understood this? First we start from the decimal number. What is the first number in the decimal?
0.
0. Next, 1, 2, 3, 4, 5, 6, 7, 8, 9. Now one digit set is over now. Then we have to write the second digit set. So in the second digit set, we have to start with 0 or 1. What we started here? The one digit. We started with 0 or 1.
0.
What do we start? 0. Then two digit set also we should start with 0, no? Am I correct?
Yes, sir.
So we have to write 0 0, then 0 1, then 0 2. We have to write like this, no? But why don't we take this 0 0 0 1 0 2?
Sir,
Hmm.
like
Yes.
if we go to three digit, four digit, it will become like 0 0 0 1, 0
Uh,
0 0.
yeah. Actually, now only we said, na, this is a whole number or the fraction number. This two digit number I am shown 0 0. Whole
Whole number.
number, whole number. In the whole number, if you place the 0 on left side, the value won't be changed. Am I correct? Yes or no?
Yes,
Now,
sir.
actually, what is this value now? This is 0. Already we have taken 0 or not in the sequence?
Yes, sir.
0 is there. Okay. And similarly, 1 is there or not in the sequence? Yes. And 2 also there. And if I write 0 3, what is the equivalent value? That is 3. So the 3 also available in the sequence. So that's why we don't want to write 0 0 0 1 0 2 0 3 up to 0 9. Okay, already we have taken. So what is the next value? What's the next value?
1 0.
1 0. You got my point. Next
1 1 1.
1 1. Then
1
1
2.
2, 1 3, 1 4, 1 5, and 1 6 is goes on. I have a doubt. This concept only for decimal number or the binary octal hexadecimal also?
Only for decimals.
Only
I
for the
think.
decimal. No, this concept is applicable for the binary octal hexadecimal also. The only thing is in decimal the set has 10 different numbers, 10 different digits from 0 to 9, and the binary set has only two digits, 0 and 1. Octal has 8 different digits, 0 to 8, and hexadecimal has 0 to f 16 digits. Actually here a b c d e f are digits, not letter. Okay, so we start with the binary. Now binary set has only two digits. What are that? Two binary digits. What are that?
0 1.
0 1. Now one digit set is over. What is the two digit set beginning number?
1.
1 two digit beginning. Actually what do we write? 0
1.
0 0 1. Am I correct? Generally, okay. If I write 0, 0 means what is that value?
0.
0. If I write 0, 1, what's that value?
1.
1. These are available?
Yes, sir.
Yes. So what is the next number? What's the next number?
1, 0.
1, 0. You got my point. Now what you have to do? You have to assume this is like this 1 is nothing but
0.
this is like 9 in decimal. In decimal system, what is the value of 9 plus 1? What's the value of 9 plus 1? 10.
10.
10.
Similarly, in the binary number system, 1 is the highest number. So 1 plus 1 equal to 10 here. Okay. So 2, if it is decimal number 2 means what is the equivalent of binary value?
1, 0.
1, 0. Now I have to add 1. Okay. So where should I add? I should add 1 in the MS. This is called MSB, most significant bit. Is it visible to you, the marked line?
Yes, sir.
Yes or no?
Yes, sir.
Okay. And this 0 is called LSB, least significant bit. Now where do we add 1? With the MSB or the LSB? 2 plus 1, the next number is 3, no? 2 plus 1, it's 3. For 2, we are writing 1, 0. For 3, how do we write?
1, 1.
Yeah, your answer is correct, 1, 1. Where do we add? At the LSB or the MSB?
LSP.
LSB. Okay, 0 plus 1, what's that value?
1.
1. Okay, in the MSB already we have 1. So this is the answer. What is the biggest number in 2-bit binary?
1.
1, 1. This is the
1, 1.
1, 1 is the. So next we have to start with the 3-bit number. Now tell me what I have to write after 1, 1.
1, 0, 0.
Yes, you are correct. 1, 0, 0. Any doubts in this?
No, sir.
Any doubts in this? Everyone, please raise your hands. Please raise your hands. Only
If we have
2.
doubts, sir.
Yes, tell me.
If we have doubt, we should raise our hands, sir.
No, no, no. If you don't understand, please raise your hands. Okay. What is the value? What is the next number to 99
100.
in decimal? What's the next number to 99? It's 100.
100.
Am I correct?
Yes,
The
sir.
same concept in 2-bit binary. Here 1, 1 is the biggest number in the 2-bit. So what is the next number? 1, 0, 0.
Yes.
What is the next number?
1, 0,
Where
1.
should I 1, 0, 1? Where should I add 1? At the MSB or the LSB?
LSB.
What is the LSB value? Is this 0 or this one? Which is LSB?
Right one.
Right.
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 Okay. This is the LSB. Now we have to add. So 100 plus 1. What's that value? 1, 1.
101.
And next, what's the next number?
1, 1, 1.
111 or 110?
110.
110.
110.
Am I correct? 110. The next number is 111. And next number, what is the biggest 3-bit number? 111. It's
11.
over. Okay, then
1000.
1000. Then 101. 1010 This is the first class. You just understand the concept. After hearing each and every class, easily it will be by heart. You can by heart it everything. Okay, you don't worry about that. 1100, 1101. Then
1110.
one and last one is the 5. How to write 16? 1
1.
4 zeros. Okay. Now the same concept we have to apply for octal also. But what is the difference between binary set and octal?
Octal we can write to 0 to 8.
8 or 7?
7, sir.
7.
7.
Actually, 8 different digits are there,
Yes.
but it starts from 0. Okay, so up to 7 there is no difference between decimal and octal. After that it changes. So 0, 1, 2, 3, 4, 5, 6, 7. What's the next number?
10.
10. Yes. Next number?
11.
11, 12, 13, 14, 15, 16, 17. Then 18 is there in octal?
No. 20.
100.
20. Yes, 20 to not 100,
Not
20.
20.
Okay, we can go up to 77. Okay, and hexadecimal 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Instead of 10, what do we use?
A.
Yes, you are correct. We are using A, B, C, D, E, F. That's all. Okay, next. Now one digit one digit hexadecimal is over. Next, two digit hexadecimal. What is the beginning of the two digit hexadecimal? The same concept.
10.
10. Okay, and the next number is 1 like this. Now, any doubts in the decimal number sequence, binary, octal, and hexadecimal? Yes, any doubts?
No, sir.
No doubt. Okay, now you know what's the need of the octal, hexadecimal, binary. Am I correct? And how to write the sequence of that.
Yes, sir.
So system can understand only binary. When we are going to feed these binary numbers, what we are doing, we are grouping as a 3-bit number and 4-bit number for easily our understanding purpose. To understand easily, we are using, but anyway, the system can understand only the binary numbers. No doubt on this. Okay.
Yes, sir.
So now we will see how to convert one number system to another number system. Suppose if I have the decimal number, how to write the equivalent binary number, or how to write the equivalent octal, or how to write equivalent hexadecimal, and vice versa. So that now we will discuss. Okay. So please take a snap of this. Anyone tell me what after taking the snapshot, what did you understand from this? What we can understand from this? Yes. Shall I ask you a question? Can you answer it? I have a octal number. I want to convert it to binary. Should I convert to decimal, then binary, or directly I can convert to binary? I have a octal number. I want to convert it to binary. Can I convert it directly, or I should convert to decimal and decimal to binary? Anyone tell me? Have you got it?
So we can do it both ways, I think.
Not both. Which is efficient? See, if I
Directly to binary.
directly, actually, I want to go to Chennai from Hyderabad. I can go to Chennai to Hyderabad in many ways. Directly, I can go from Chennai to Hyderabad, or I can go to Mumbai, then Mumbai to Hyderabad, or I can go to Mumbai to Delhi, Delhi to Kolkata, Kolkata to Hyderabad. So there are so many ways are there, but which is the opt one?
Direct.
Direct. The same thing here, if I have the octal number and if I want to convert to binary means this process directly I can do it. So that's why they are given the thick line. Okay. And similarly for if I want to convert binary to hexadecimal, I can easily convert it. I don't want to go for the decimal. Suppose I want to convert decimal to hexadecimal. What do we do? Decimal to hexadecimal or
First
decimal to
binary, then
octal?
hexadecimal.
Pardon?
So first
First,
binary, then hexadecimal.
first binary, then
Hexadecimal.
hexadecimal. Okay. Either I can do this way or I can do this way. Okay. And hexadecimal to decimal. What I have to do? Hexadecimal to decimal. It's our wish. You can go to binary, you can convert to binary and binary to decimal, or directly you can convert this thing. So please make a note wherever you are having a thick line, one conversion means directly you can go it. Suppose if you have two conversion means you have two options. Either you can convert, for example, hexadecimal to decimal means there are two options. You can go to hexadecimal to binary, binary to decimal. This is one of the way. Or another way, directly you can convert hexadecimal to decimal. So this we will see one by one. Okay. Now the given number is a binary or what? What is this? The given
Binary.
number? Binary. No, how did you convert this binary to octal? We converted directly or we use the help of the decimal?
Directly.
Directly. Okay, similarly, the binary to hexadecimal, directly
Directly.
we can convert that. And the vice versa also. For example, if the hexadecimal number is given and they are asking the binary means directly you can write it. 0 can be written as 4 zeros. A can be written as 1010.
1010.
7 can be written as 0 triple. So like this, what you can do means you can directly convert without the help of the decimal number. Okay. Now we will see how to convert the decimal number system to other base number system. Okay. We will take one example. We follow the same method for converting octal and hexadecimal. Okay. I'll take one fractional number. Okay. Okay. Is it visible to you?
Yes, sir.
Okay. Now given number system is here. Decimal, binary, octal or hexadecimal. What's it? Given number. The 12.75 is a decimal,
Decimal.
octal. How do you know it's a decimal?
The base 10.
Base 10. Yes, please make a note. Please make a note. Because sometime this 12.75 may be a hexadecimal also, but this there are three options for this, because 2 won't come in the binary, but this 2751 may come in the octal, hexadecimal and decimal. So you should know what kind of number system is given. So how can you find out means the base number. This is called base number. The 10 is given, no? Now this is called base. If base is 10, it's a decimal. If base is 8, it's a octal. If the base is 16, it's a hexadecimal. Okay, now what's the base value? Base value is 10. Now what is this? This is a decimal number. Okay. So now what I have to do? I have to convert this decimal number to binary number. Okay, decimal number to binary number. What is the base value of decimal number? What is the base value of decimal number? Sorry, binary number?
2.
2. Now what we have to do? We have to take the base value of the destination number system. So in our case, the base value of the destination number system is 2. So this 12, the whole number should be divided by the base value of the destination number system till the remainder is lesser than or equal to the base value. Okay, and each time you should consider, you should take only the quotient, and remainder you should keep it separately. We will take later on. So first we are taking 12. So the given the whole number is 12. Am I correct? So this 12 is given. Now this 12 by 2. So what is the value of 12 by, if you divide 12 by 2, what will you get? What is the quotient and what is the remainder? Quotient is 6 and remainder is 0. In the next iteration, you should take the quotient value. Don't take the remainder. You have to note down the remainder, but don't take the remainder for the next iteration. You have to take the quotient. So this again you should divide by 2. So you will get quotient is 3 and remainder is 0. This 3 is greater than 2 or less than 2? 3 is greater than 2 or less than 2?
Greater.
Greater than. Okay. Can I go one more iteration, or I can stop here?
We
When
can
do
go.
we stop the iteration?
It is less than or
And
equal.
less than or equal.
Yes. Quotient or remainder, which is less than or equal to?
Quotient.
Quotient, because remainder is always less than, no? Am I correct?
Yes.
So now I should go for one more iteration. If I go for what is the quotient? Quotient is 1 and remainder is 0. Can I go one more iteration, or should I stop here?
We should stop.
Stop, because 1 is less
Less
than
than 2.
2. Okay. Now if it is the whole number, we should divide by the base of the destination number, and each time you should take the quotient of the previous stage. Okay, and this process has to be done till the quotient reaches less than or equal to the base value of the destination number system. Suppose if I want to perform, if I want to write the same 12 in octal, what should I do? What changes I have to do here? Anyone tell me? I want to write the 12, this decimal number to octal number. What should I do?
So divide by 8 instead of 2.
Divide by 8. Can you tell me what is the equivalent octal value? How many iteration it will come? One iteration or two iteration or three iteration or none? How many
So
iteration?
one.
One iteration. What is the quotient and what is the remainder?
So 4 is the quotient and
4 is the quotient.
1 is the quotient and
1
4
is
is
the
the remainder.
quotient
4 is the
and 4 is the remainder.
So,
Okay. Yes, yes, tell me.
didn't you just say that we can't directly convert decimal to octal? We have to go through binary first.
Decimal to octal.
Octal?
Yeah, yeah, that is another way also. That is another way. This is direct approach.
All right.
Okay, this is direct approach. Directly you can convert decimal to octal. If you divide by 8, directly you can convert. In another approach, what you can do, decimal to binary and binary to octal. So that you should group 3 bits. After writing the answer in binary, you have to write the equivalent octal value for that. Okay.
Yes.
Now you know this, and the last and one more thing is that you have to write the answer in the bottom up approach, and you have to start from the quotient. The last actually this is not okay, the last quotient you have to start from the last quotient, because this is like a remainder only, because this value is lesser than the base value, no? So you have to start from here, this one, and you should go in the bottom up approach. Now what is the answer? Is it 1100 or 100? What is the answer?
1100.
1100. So please make a note. You have to start, you have to write it in bottom up approach, and you have to start from the last stage quotient. Some students will do mistake here. They will consider, they will write only the remainder. They will forget about the quotient, but it's not like that. We have to start from the quotient of the last stage. Okay, so what is the answer now? 1100. So that is equivalent to binary. What is the equivalent of octal? Anyone tell me? What is the equivalent of octal?
14.
1 4. Am I correct? And what is the base value of octal?
8.
8. Okay, suppose if I want to write the equivalent of hexadecimal, what is the answer?
None, sir.
None. Yes, you are correct. But what is the value of that? What do we write? How do we write 12 in hexadecimal?
C.
Yes. Now what you have to mean, so you should type C only here. Instead of 6, you have to type C, and this is 0. Okay, actually here we don't, sorry, I made mistake. Now this place is 0, the 6th place is 0, and here you have the 0 places, you have to write C. You got my point? What do we type here?
0.
0. And what do we type here?
C.
C. Okay. Now if you go for bottom up approach, what will you get? 0 C, nothing but C. Am I correct?
Yes, sir.
Because there is no quotient here, only the remainder. 16 is greater than 12. So you will have only the remainder, you won't get the quotient. Okay. So whole number conversion means you should remember the division. Okay. And the process you know how to stop and when to stop. And for the fractional number, just opposite of that, you have to multiply by the base value of the destination number system. Okay, the base value is what? 2 of the binary number system. You should multiply. So 0.5 into 2, how much? 0.5 into 2, how much?
1.
0.5 into 2. Is it 1 or 1.5? Sorry, I made mistake. Sorry, you are correct. 0.5 into 2 is 1. 0.75 into 2. Sorry, I made mistake. It's my mistake.
1.5.
Yes. 0.75 into 2, 1.5.
5.
What is the whole number value and what is the fractional value?
1 whole,
1
0.5
is the whole
fractional.
number and 0.5 is the fractional number. Here, the next iteration, you should take the fractional number. Please understand. What is the fractional value of 1.5?
0.5.
0.5. So this 0.5 should be multiplied by 2. So 0.5 into 2 how much?
1.
1. Is there any fraction?
No, sir.
No. Okay, if there is no fraction means we can stop it. What's the reason?
Multiplication
Is 0. Am I correct? So when do we stop this process?
when
When
the
there is
remainder
no
becomes
fractional
0.
value.
Fractional part becomes 0.
0. So please make a note. Okay. Fractional part, what you have to do? You have to multiply by the base value of the destination number system and you have to multiply it and note down the result. For the next iteration, you have to take only the fraction of the previous stage and you have to repeat the same step till the fraction part reaches to 0. So sometime it will repeat some numbers. For example, if you take 0.1 or 0.2, the numbers will be repeated. If the same number will be repeated means what do we means? We can stop. You can stop somewhere. You don't want to write the repeated again and again. Okay. Now any doubts in this? How to convert decimal numbers to other number system?
No, sir.
No. Suppose if I want to write the 0.75 in the octal, what should I do?
Multiply by 8.
8. Okay. What is the value of 0.75 into 8?
1 to 8. 6.
6. And I forgot to say that in the whole number, which approach we followed? Bottom up approach or top down approach for the whole number for writing the answer?
Bottom to up.
Bottom up approach. And each stage we consider the quotient. In each time we consider the previous stage quotient and we just note down the remainder. Finally we use the remainder. But here just opposite. Now what do we do means we have to do the top down approach here. Each time what do we have to? We have to note down the whole number and the fraction value. But for each stage you are using the previous stage fraction. That means you are using the whole number for writing the result and you have to use the bottom up approach. Sorry, top down approach. This is a fraction for top down approach and the whole number for bottom up approach. The arrow mark. So please note down the arrow mark, then easily you can understand. So if it is 0.75 in the decimal, what is the equivalent of octal value?
6.
6. Okay. Only the 6. So that's all about that. So you can simply write 12 point. So how can I write 12.75 in binary? 1100 dot 11. Okay. So this is one of the way. If you know the binary value, directly you can write it in octal and hexadecimal. So anyone tell me what is the octal equivalent value? What is the octal equivalent value?
14.
14, yes. 110. What is the equivalent of 110? 6.
6.
Am I correct?
14.6.
14.6. If I want to write the hexadecimal, what is the value of 1100? C. C dot
1100 C.
again C dot C. Am I correct? Some student, what do we do? They will write the fractional part as 6. They will write C dot 6. Is it correct? Which is correct? C dot 6 or C dot C? Which is
C
correct?
dot C.
C dot C. Okay. So hexadecimal means 4-bit group and octal means 3-bit group. So please make a note. Why I am telling you, these are the places student will lose the marks. So that's why I'm telling you. Okay. So please note down. Okay. Any doubts? Any doubts?
No, sir.
Okay. Thank you.